Hello everyone, I am Ravi Kumar. I am going to start new series on structural engineering where most of the students are feeling it's very difficult subject, and of course it is difficult if you are not clear about your concepts and if you are not strong in your basics. So please give your full attention for the basics. So I am starting with basics, starting from purpose of any structure, types of loads and types of support, such as simple concepts like that I am starting, and then I will be going till analysis and design of structures by using StatPro, ETAP, SAP, etc. So let's start with the basics. Today I am going to start about the discuss about the purpose of any structure. Let's start. So whenever we are going for a structure, we need to understand what is the purpose of the structure and why we are constructing the structure. First, we'll go for the purpose of the structure. We have two types of construction mechanism. That is, one is load-bearing structure and frame structure. So you need to understand the main purpose of the structure is to transfer the load which is coming on the building to the foundation. And we have substructure as foundation and superstructure as a structure above the ground. The load will be coming on the structure, and each and every floors you will be getting the loads. That load should be transferred to the foundation. For that we have beams and columns in case of frame structures and walls in case of load bearing structures. We will discuss about load bearing structure and frame structure in detail in one of the class. Now let's go with the main purpose of the structure and what you need to achieve by transferring load to the foundation. As you can see in this picture, we have load bearing structure. In load bearing structure, the load will be transferred through the walls, what you can see, and you will not be having any beams and columns here. In frame structures, you will be having beams and columns, which are the main things will be transferring loads from the floors to the foundations. That means from superstructure to the foundations. While transferring loads, as most of the structures today are frame structures, I am taking frame structure as an example. If I take this frame structure, so as I told you, the loads will be coming on the floors that has to be transferred to the foundation, and you need to achieve the two important things, the safety and economy. So you can't compromise with safety as well as with the economy. Of course, various methods are available to achieve near to 100% safety, and the skill of civil engineer or structural engineer depends on how economic you will make the structure, how economic structure will be. So that is the main thing we need to achieve. You can't compromise with any of these two things. So as we need to transfer the loads which are coming on the structure to the foundation, first let's think about the types of loads. So before going to types of loads, the various nature of loads which are coming on the structure, we can discuss about that. So we have the dead load. The self weight of the structure itself is called as dead load. It's the self weight of the structure. So normally how we will get is, if you are taking length, breadth and height of the structure multiplied by the density of concrete in case of concrete structures, density of steel in case of steel structures. If you multiply that, this you will be having meter cube, and this unit of density will be kilonewton per meter cube. So you will get kilonewton, that is the weight of the structure, and that is the main thing. Most of the structure should have resist, should be capable of taking that loads. That's why the failure of dead load is the main cause of the structures which are failed during the construction itself. Next we have the live load. So based on the purpose of the structure, like we will be having residential structures, we will be having industrial structures, commercial, like various types of purpose will be there. Depends upon this, we will be applying load on that. Suppose if you take the residential load, human beings will be there, and then furnitures will be there. Industrial, in the case of industries, you will be having machineries. machineries are the main thing, and also human beings will be there, all those things will be there. So that will be called as live load. Why we are calling it as a live load? It is it will be changing. That means it will be keep on changing. We can apply the load, we can remove the load if you are using the building for any other purpose. And dead load is the self weight of the structure itself. Suppose if you take a beam, the weight of the beam itself is a self weight. The weight of the beam will not change throughout the lifespan of the structure. That's why it is called as dead load. So these are the two things you need to consider, even if you are taking even single sway, that is single story portal frame also. So you need to take this. You will be having the dead load plus live load. Any structure should be designed for dead load plus live load. Then we will be having based on the location of the structure, we will be having the snow load, we will be having the earthquake load, will be then if the structure is constructed in hilly areas or the high rise structures, the wind loads are the main important things. Then we need to go for the blast loads if the structures are some of the things which are hazardous buildings. So all things will be taken care when we are going for the type of loads. So whatever may be the load, either it is dead load, live load, snow load, or whatever it is, as I told you, we need to take two things that is very important, that are the basic loads which we need to take into account. Based on the action of the loads will be classified, and that is the main thing I am going to discuss today under the heading of types of loads. So when we are going for the types of loads, say first one is the point load. If I take an example of small beam which is simply supported like this, if I apply load and if I mention the magnitude of that in kilonewton, P kilonewton is a point load. It is also called as the concentrated load. Actually that is the meaning. The concentrated load is the important thing, and that is the real name of the point load. You need to call it as concentrated load. And if you take this beam, what you can see, for example, suppose if I take a hall of having some length and width, and if the human being is standing on the structure, is the area of this man is standing on the structure is very negligible compared to this length and breadth. And also if you take the hall, the laboratory, for example, if you take any machine which has been installed at the center or at some place of this hall, the compared to this length and breadth, this area is very less, and you can consider that as a point, or it is called as concentrated load. The unit of that will be kilonewton. So suppose P, the load, concentrated load acting, so we can call it as P kilonewton, either 10 kilonewton, 15 kilonewton, 20 or something like that. So kilonewton, P kilonewton. Next type will be having UDL, that is uniformly distributed load. Uniformly distributed load. So that we can write it as like this, and if it is P, the unit of that will be kilonewton per meter. Uniformly, as the name itself indicates, it's uniformly distributed load, distributed throughout the span of the beam. If I take a beam, so this is what you will be having the P. How we are calculating, you can write it like this also. If this is a beam, so this will be distributed. Since it is uniformly distributed, you can write in the form of rectangle, and the load also can be calculated. The intensity of the load we are applying is P into L. So that is the load whatever we are getting on this. So it is P kilonewton meter. The load intensity can be calculated by P into L. Next we have uniformly varying load. Uniformly varying load. If I take the same beam, if the load is varying from one end to other end like this, see in this case we have 0 here, we have the maximum, it can call it as P kilonewton per meter. So per meter it is increasing like this from 0 to P. So it is uniformly varying. That means if you take at the center of that, it is exactly half of the load. So it is in the form of triangle. So we can take, this is the L, this is P, and you can take the load intensity as half into P into L. So that is how we are calculating the magnitude of load in the case of uniformly varying load. So these are the different types of loads what we have, and of course we will be having another type of load also, that is uniformly, non-uniformly distributed load. So it is not uniformly distributed, it is distributed. Somewhere it is 10 kilonewton, one side it is be 100 kilonewton, and one side it is 0, and after that point it will be having 5 kilonewton. So it is non-uniformly varying load. So as the basic, we'll start with uniformly distributed load or uniformly varying load. We'll concentrate more on concentrated load, uniformly distributed load, and uniformly varying load, what we have discussed here. So after applying the load, it has to be transferred to the foundation by achieving safety and economy, as we have discussed. For that, we need to give the supports. So what are the different types of supports? We'll discuss about that. Normally, 4 basic types of supports are there. So I'll write one by one. The first one is we'll say it is fixed support. Then we have hinged support or hinge or pinned support. Next we have simple support and also the roller support. Normally we will call it as roller. So let's discuss this one by one. As I have written, this is a beam, and if you are having beam, if you have not given any support, by looking at this only you can tell that it can move in horizontal direction and it can move in vertical direction, either upwards or downwards, either right or towards the left, and it can rotate also. If I take this beam can rotate like this, right? So due to the load we are applying on that, it can rotate in the other way also. It can move in this direction, it can move in that direction. If I take one point, this beam, if I give the fixed support will be written like this. That is the fixed support. So other side also I am giving the fixed support. That means if I am supplying or if I give fixed support for any element, it will not move in horizontal direction, it will not move in vertical direction, and also it will not rotate. So fixed support offers resistance in vertical direction. Normally we will call that resistance as horizontal reactions. Resistance in horizontal reaction, and this is the moment. So fixed support will be giving resistance for all these. Here also you will be having this one vertical reaction, horizontal reaction, and also the rotation. And how much resistance it will offer per a particular load. Say I am having some load of uniform distributed load and also I am having point load on this. For based on this, how much this support will give, how much this support will give, that we are calculating in the subsequent chapters. And now you need to understand that fixed support is the one which will give resistance in the horizontal direction, vertical direction, and also for the rotation, that is the moment. So guys, now we have understand the fixed support. We are writing support like this. It will give resistance in 3 directions. One is for rotation, vertical reaction, horizontal reaction, and moment. So how many unknowns you need to calculate? 3 unknowns. This we will call it as number of unknowns is 3 in case of fixed support. Next we have the hinge, that we can write it like this. The best example for the hinge is the door. If I take this door, how the door will be? You will be having the door. The door can rotate, that means it will move in and it will come out. So that means it can rotate, but it will not move in horizontal direction and it will not move in vertical direction. So that means hinge will offer resistance in the vertical direction, that we can calculate as vertical reaction. It will offer resistance in horizontal direction, that is horizontal reaction, RH. So the number of unknowns in this case is 2. This support is hinge or pinned support. So next we have the simple support. So it's very simple support. Most of the engineers and most of the tutors will use this as the basic example for calculating the reactions and also for the teaching purpose, because of its simplicity. As the name itself indicates this, it will give resistance only in the vertical direction. That means if you are having the beam like this, it will not allow this beam to move in this vertical direction. It will not move in this vertical direction if I give the simple support. So it will allow this to move in this direction, but it will not allow this beam to move in vertical direction, and it can allow the beam to move or rotate. So that means moment will be there, and this horizontal movement also will be there, but vertical movement will not be there. So that's why we need to calculate the vertical reaction. So number of unknown you need to calculate in this case is only 1. So this support is called as the simple support. Next we have one more thing, that is roller support. Please give your attention in this. You might have seen some of the gates which are moving from one side to another side. The best example, if you can take the tire of a vehicle. What this tire or wheel will do, it will allow this vehicle to move in horizontal direction if the tires or wheels are provided in this direction. But it will not allow this to move in vertical direction, and it can rotate also. The vehicle can rotate also. So that means the roller support offers resistance in the vertical direction. If I providing like this, it will offer resistance in the horizontal direction if I provide this as vertically, and also the roller support offers resistance if I provide like this, it offers resistance in this direction. By looking at these pictures, you can understand that the roller support offers resistance in the direction perpendicular to the plane of the support. If this is the plane of the support, see, this is the plane of the support, perpendicular to this, it will offer resistance. So only one reaction will be there, and that will be perpendicular to the plane of the support. So perpendicular to the plane of the support. Please remember this, it is perpendicular to the plane of the support. So number of unknown is 1. So that is horizontal or vertical or anything. It may be inclined also. So this is what the roller support. The main important thing you need to understand between simple support and roller support is that the roller support offers resistance in the direction perpendicular to the plane of the support, but simple support, it is always vertical reactions. So if it is horizontal plane, it will be vertical resistance. So number of unknowns in this direction is 1, number of unknowns in this direction is 1. Now there is a concept called degree of freedom. If you are in the higher semester, or if you are completed your basic civil engineering subject, you may be knowing that what is degree or degrees of freedom. See, this is a beam. As I told you, it can move in this direction, it can move in this direction, and it can rotate. If it is moving in this direction, that is degrees of freedom. It can move in this direction, degrees of freedom, that is 1 degree of freedom. It can move in vertical direction, that is another degree of freedom. And this can rotate, that is 1 more. So that means at a plane structure, at a plane beam element, at one end you will be having 3 degrees of freedom. So 3 degrees of freedom will be there that you need to resist. In case of simple support, what we will do? In case of simple support, we will give resistance in vertical direction. In case of fixed support, we will give resistance in all the directions. That means if I provide the fixed support, it will not allow this to move in this direction, it will not allow to move in this direction, and it will not allow the beam to rotate. So degrees of freedom in this case is 0. That means it will not allow them. If it is allowing, see, simple support, it is not allowing in the vertical direction, but it will allow in horizontal direction, it will allow for rotation. So that's why here you will be having 2 degrees of freedom in simple support. In hinged support, where we have the hinge support, will be not be allowing horizontal direction and vertical direction, but it will allow for the rotation. So degrees of freedom in case of hinge support is 1. Can you tell me degrees of freedom in the roller support? Of course, this degrees of freedom in the roller support is 2. So you need to understand the degrees of freedom is 0 in fixed support, 2 in simple support, 1 in pinned or hinge support, 2 in the case of roller support. What are the degrees of freedom? In this direction, there is no movement in any direction. In this simple support, you will be having horizontal movement and rotation. That are the 2 degrees of freedom. In this, you will be having rotation. That means it will not give resistance for the rotation. That is the meaning of that. That is 1. In this, it will allow, if this is the plane, it will allow the beam to move in horizontal direction, and it will allow the beam to move for the rotation. So that is 2 degrees of freedom. This is the meaning of degrees of freedom you need to understand. So in the fixed support, you will be having degrees of freedom 0 and number of unknowns 3. In simple support, degrees of freedom 2, number of unknown is 1. That is our vertical reaction. In the pinned support, you will be having degrees of freedom 1, number of reactions are 2. In the case of roller support, degrees of freedom is 2, number of reaction is 1. That means our number of unknown is 1, which is perpendicular to the plane of the support. Now all of you are clear about types of supports. So based on the types of supports, the beams will be classified into various types. So based on the types of support. Example, the types are simple supports, simply supported beam. If you have a beam supported both ends by using simple supports, this is called as simply supported beam. So I can apply the load, the point load. See, this is called as simply supported beam with point load. How many number of unknowns are there in this? See, here it can move and it can rotate. Number of unknowns is 1. Degrees of freedom here is 2. Number of unknown, the vertical reaction is 1. Degrees of freedom are 2. So total how many degrees of freedom? 4 degrees of freedom in this simply supported beam. Number of unknowns you need to calculate is, this is degrees of freedom. Number of unknowns you need to calculate is 1 plus 1, 2. So that is simply supported beam. Next we can take it as fixed beam. The beam which has been supported both sides by using fixed support is fixed beam. That's it. See, number of unknowns here you need to calculate is 3. Horizontal reaction, vertical reaction and rotation. Here also same thing, number of unknown is 3. So total number of unknowns you need to calculate in this case is 6. Degrees of freedom in this case is 0. Here also 0, here also 0. Next we have combination of this. See, one side fixed support, another side we don't have any support. So now we need to apply the load for this. So I will tell you where which types of building, which part of the building you may encounter these types of beams, and which part of the structure of different structures you will be seeing this. I will explain all these things. So now we'll go for this. This is called as the cantilever. So one side fixed support, another side free end. This is called as cantilever. So you can apply the point load, uniform distributed load, uniformly varying load, whatever it is. So this is the fixed support. Number of unknowns you need to calculate is 3. Degrees of freedom, this is very important thing you need to remember. Here it is 0, but here there are 3 degrees of freedom. So degrees of freedom in this case is 3, but not at the fixed support, but at the free end. This is known as cantilever. Similarly, based on the types of support we are applying, one side hinge support, one side on the roller, and you can also make the combinations in such a way that you will be having simple support, another side fixed support. This type of beam is called as propped cantilever. This end is known as prop or propped end, or simply prop. This is propped cantilever. So these are all the different types of beams we are having. We can also have the continuous beams. See, simple support, simple support, simple support, or you can have the hinge support, and one side you have the fixed support. See, different beams in the same line. So that is, we have the fixed support here, hinge, simple supports continued. So it is known as the continuous beams. Continuous beams. So these are all the different types of beams, and based on the different combinations of supports, we will also be having different types of beams. They are called as based on the supports. This is about types of beams. And one more thing you need to understand about types of beams is, see, all of you know, if you are having number of unknowns 3, we need 3 equations to calculate number of unknowns. And if you are having number of unknowns 2 equations to calculate number of unknowns. So based on this, we have 3 equilibrium conditions. In this structure, in the structural analysis, we are having 3 equilibrium equations or 3 equilibrium conditions to make the structure to be in equilibrium. Suppose if I take this building, I will take this part of the beam. So I will write here, we will be having fixed support here, and whatever may be the support, continuous, fixed, or whatever it is, we don't want this beam to move in vertical direction, horizontal direction, as well as we don't want this to rotate. So that means completely it should be in rest. So that means it should not move in horizontal direction. Sigma Fh is equal to 0. Algebraic sum of all the forces in the x direction or horizontal direction should be equal to 0. And at the same time, it should not move in vertical direction. Algebraic sum of all the forces, if we take, it should be equal to 0, and it should not move in, it should not rotate in any direction. That means algebraic sum of all the moments should be equal to 0. Let's understand this. Suppose if I am having a beam, if I am having vertical load like this, see, F1, and it will move in this direction, it will move in vertical direction downwards. If I give one more load in this direction, F2, see, if I take the sign convention, if this is negative and this is positive, normally we will take this upward positive, downward negative. Algebraic sum, see, minus F1 plus F2 should become 0. For this, F1 should be equal to F2. Of course, if you are having different types, 1, 2, and only one force in this direction, or 3 force in this direction, let us call this as F1, F2, F3, and F4, F5. So this is downwards, we are writing this as minus, this is upwards, we are writing this as positive, whatever it is. If I take sum of all these things should be equal to 0. That is in the case of vertical. As well as in the horizontal direction, if I am having any body and horizontal forces are acting in these directions, that also should be equal to 0. At the same time, it should not rotate also. So the equilibrium conditions are there. They are 3 equilibrium conditions. Now you understood the equilibrium equations are 3. So that means sigma Fh is equal to 0, sigma F V is equal to 0, and sigma M is equal to 0. Now go for any one example. If I take a fixed beam which is having fixed supports on both sides of the beam, if I take this, number of unknowns here is 3, number of unknowns here is 3. But equilibrium equations to solve this we have is only 3. So 3 equations of equilibrium will not enough to solve 6 unknowns which are there in this. So that's why this type of beams will call it as statically indeterminate beams. Statically indeterminate beams. And if the number of unknowns are less than or equal to equilibrium equations, we can find the unknowns by using equilibrium equations only. They are called as statically determinate beams, statically determinate beams. So example, if I take simply supported beam, see whatever the load I am having, number of unknowns here is 1, number of unknowns 1. So total number of unknowns in this beam is 2. This number of unknowns can be calculated by using equilibrium equations, which are 3. In fact, 2 equations are enough to calculate number of unknowns. Even if I take a cantilever also, if I take a cantilever, how many number of unknowns are there? 1, 2 and 3 number of unknowns. So 3 number of unknowns can be calculated by using 3 equilibrium equations. So this we can call it as statically determinate. So to summarize this, what are all the things we have completed in this video? We have understood the purpose of the structure. The main purpose of the structure is to transfer the loads which are coming on the structure to the foundation by achieving safety and economy.